You all for a brief video presentation on the topic Constraints in SQL of the subject Database Management Systems. Hello, I am Bharath M of 4th semester Computer Science and Artificial Intelligence Department at Sri Venkateswara College of Engineering, Bangalore. The subject I'll be discussing through this video would be Database Management System and the topic is Constraints in SQL. Now, let us look at Introduction to SQL Constraints. SQL constraints are rules applied to database columns to ensure the accuracy, reliability, and integrity of the data. They enforce specific conditions that a data must meet to be accepted into the database, thereby preventing invalid data entry and maintaining consistent data standards. Constraints are crucial for defining the relationships between tables and for upholding the quality of the database. By using constraints, developers can ensure that the data adheres to business rules and requirements, facilitating efficient data management and reducing errors in database operations. Next, let us look at what is the importance of constraints in SQL. Constraints are vital in SQL as they ensure data integrity and consistency within a database. They prevent the entry of invalid data by enforcing specific rules and conditions, thereby maintaining the accuracy and reliability of the data. Constraints help in upholding business rules, ensuring that the data adheres to the required standards. They also enhance database performance by reducing the need for extensive data validation checks in application. Overall, constraints play a crucial role in effective database management, enabling robust data control and supporting the integrity of relational databases. The next one is types of SQL constraints. SQL constraints are mechanisms to enforce rules on data in tables. The primary types include not null, which ensures a column cannot have a null value; unique, which ensures all values in a column are unique; primary key, a combination of not null and unique, uniquely identifying each record; foreign key is ensuring referential integrity between tables; check, enforcing a condition on values in a column; and default, providing a default value for a column if none is specified. These constraints are essential for maintaining data integrity, consistency, and adherence to business rules within a database. Not null constraints. Let us look in depth about the not null constraint, which ensures that a column cannot have a null value, meaning every row in the table must have valid entry for that column. This constraint is crucial for columns that require mandatory data such as a user ID or email address. By enforcing not null, SQL guarantees that essential information is always provided, thereby preventing incomplete or missing data entries. This constraint helps maintain data integrity and reliability, ensuring that critical fields are always populated with meaningful values in the database. The next is about the unique constraints. The unique constraint ensures that all values in a column or a group of columns are distinct across the table, preventing duplicate entries. It is essential for columns where each value must be unique, such as email or addresses or usernames. Unlike the primary key constraint, a table can have multiple unique constraints. By enforcing uniqueness, this constraint helps maintain data integrity and prevents duplication, which can lead to inconsistencies and errors in database operation. It ensures that each entry is distinct, thereby supporting reliable and accurate data management. This is about the unique constraints. Primary key constraints. The primary key constraints uniquely identifies each record in a table, combining the properties of not null and unique constraints. A primary key ensures that a primary key ensures that no two rows can have the same value in the primary key column and it cannot contain null values. This constraint is essential for establishing a unique identifier for table records, enabling efficient indexing, searching and relationship building between tables. Typically, a table can have only one primary key, often composed of a single column, but it can also be a composite key consisting of multiple columns to uniquely identify each record. The other one is the foreign key constraints. Foreign key constraint enforces referential integrity by establishing a relationship between two tables. It ensures that the value in a column matches a value in the primary key column of another table, creating a link between the child table and the parent table. This constraint helps in maintaining data consistency by preventing actions that would leave orphaned records in the child table. For example, it prevents the deletion of a record in the parent table if related records exist in the child table, thereby preserving the integrity of relational data. Next is about check constraints. The check constraints enforces domain integrity by specifying a condition that each value in the column must satisfy. This condition is a Boolean expression for any data entry that does not meet the criteria rejected by the database. For example, a check constraint can ensure that the values in an age column are greater than 0, or that dates in the start date column are in the future. By using check constraint, developers can enforce business rules at a database level, ensuring that only valid and appropriate data is stored, thus maintaining data accuracy and consistency. The default constraint automatically assigns a default value to column if no specific value is provided during data entry. This is useful for ensuring that a column always has a meaningful value, even when the user does not explicitly supply one. For example, a column for created date might default to the current date and time if no date is provided. Default constraints help maintain um, data consistency and reduce the need for additional logic in applications to handle missing values. They ensure that columns have consistent initial values, supporting more reliable data management practices. Next one, composite key constraints. A composite key constraint involves using multiple columns together as a unique identifier for each row in a table. Unlike a single column primary key, which uniquely identifies each row based on one column, a composite key uniquely identifies rows based on the combination of values in n multiple columns. This constraint is particularly useful when no single column can uniquely identify a row on its own, but the combination of several columns can. It ensures that each combination of values in the specified column is uniquely within the table, supporting complex relationships and data structures in relational databases. The next one is the domain constraints. Domain constraints specify the valid values for a column based on its data type and properties. These constraints define the permissible range of values that can be stored in a column, ensuring data integrity and consistency. For example, a domain constraint on a price column in a table might specify that prices must be positive numbers, or that a status column can only contain specific predefined values, example active, inactive, etc. By enforcing domain constraint, SQL ensures that data conforms to predefined rules and business requirements, preventing invalid or inconsistent data entries in the database. The next one is referential integrity, maintained in a relational database when relationships between tables are enforced accurately using foreign key constraint. This ensures that any foreign key value in the child table corresponds to a valid primary key value in the parent table. It prevents orphaned records and maintains consistency throughout the database, ensuring that relationships between data are preserved and accurate. This is crucial for data integrity as it guarantees that any data references between tables are valid and reliable, preventing inconsistencies and errors in data operations. Next one, on delete cascade and on update cascade. These refer to actions defined on foreign key constraints in SQL database. On delete cascade specifies that when a record in the parent table is deleted, all corresponding records in the child table are automatically deleted as well. One update cascade specifies that the primary key value in the parent table is updated. All corresponding foreign keys values are in the child table are updated accordingly. These cascading actions maintain referential integrity and ensure data consistency across related data tables and database. Enforcing constraints in SQL can also be seen. Adding constraints to existing table is another part of the constraint. When you're adding constraint, there has to be something as removing constraints. There's some common mistakes which are done with the constraints and the best practices for using constraints. SQL constraints are essential for maintaining data integrity and enforcing business rules within databases. They ensure that data entries are accurate, consistent, and adhere to predefined standards. Throughout this presentation, we have explored various types of constraints such as not null, unique, primary key, foreign key, check, and default. Each constraint plays a crucial role in defining data relationships, validating input, and preventing errors. By implementing constraints effectively and following best practices, organizations can optimize database performance, reduce data inconsistencies, and support reliable data-driven decision-making processes. Embracing these principles ensures robust SQL database management and enhances overall data quality and reliability. So thank you very much for being a part of the video. See you soon in the next one.